Now we will see membrane versus shell. In membrane element, we will differentiate both. This is membrane element and here is shell element. Okay. Here in membrane element we have in membrane element in plane bending stiffness is present, but it doesn't have out of plane bending stiffness. It means out of plane bending stiffness not present. Okay, we can say not present. In shell element, in plane bending stiffness and out of plane bending stiffness both are present. Now what you mean by in plane bending and out of plane bending we will see by using this image. This is our slab. Okay, this is slab. In this slab this direction is x direction and this direction is y direction and this direction is z direction. Z direction. Okay, so in membrane this sorry for this x direction this is in plane stiffness and this y direction also it is in plane stiffness, but this z direction is out of plane stiffness. We will write this one. This x direction is in plane stiffness and this y direction also in plane stiffness and this z direction is out of plane stiffness. In our membrane this out of plane stiffness is not present, so I will write this not present in membrane. Okay, now if this is in plane stiffness means it resist the load. So this is also y direction, also in plane stiffness, so this also resist the load. But this z direction in membrane, this z direction is out of plane stiffness, so this is not present. So what happens, it does not resist the load. The load will be transferred 100% to the supporting element. In our case, supporting element means beams. Membrane will transfer the 100% load to the beams. Okay. Similarly, in shell element, in this also, this is x direction, this is y direction, and this one is z direction, right? This x is in plane stiffness, this y also in plane stiffness, this z is our out of plane stiffness. Okay. In shell element also, in plane stiffness resist the load. Same here also, it resists the load. In our shell element, both in plane and out of plane bending stiffnesses are present. So due to this, out of plane stiffness also here in shell element present in the shell element. It means in shell element, out of plane stiffness also present in the shell element. We can say like this. Okay. Now these in plane stiffness, these two x and y direction are resist the loads, and due to presence of this out of plane stiffness in shell element also, it resists the load. But first it resists some part of applied load, and then remaining load will be transferred to supporting element. It means if we model slab as shell element, then when we apply the load on that shell element, it resists some part of the load, and then it transfers to the supporting element. But in case of membrane element, it doesn't resist any load. Totally 100% the load will be transferred to the supporting elements. Here supporting elements means our beam elements. Okay. Now in membrane element, load is distributed as per yield line theory. What yield line theory tells? It's the load will be transferred. If this is our slab means this is triangle and this is trapezoidal, like this. The load will be transferred to this beam, this, and these loads will be transferred to these beams, this beam, like this. Our yield line theory load distribution is this type. Okay, but in our shell element, load will be distributed using real stiffness of slab in the model. It means in shell element it considers the stiffness, and according to the stiffness the load will be transferred. Okay, and in membrane element, here in this method, it assumes that it has same beam size and same stiffness. So in membrane it assumes that the beam size and stiffness are same in all four sides. It means if we have this one as slab means here it assuming this is slab and this one is beam B1, B2, B3, B4. Here in membrane it assumes that this B1, B2, B3, B4 all beams are same size. Beams are same size. Due to same size of these beams, the stiffness also same. So it assumes like that. Okay. But in our shell element, in this method, no assumptions. It takes exact size of beam and real stiffness. So in shell element it consider the exact stiffness with accordance to the size of that beam. Whatever the real stiffness is present, that one it captures. Okay. Now the next one is, here in membrane load distribution may not be correct due to assumption of stiffness. Load distribution may not be correct due to assumption of stiffness. Okay. In shell element, we can say here load distribution is correct and practical way because it uses real stiffness. Okay. Now another difference is in membrane, here we use longer span by shorter span, which is less than 2 means we take 2 way. If it is this longer span by shorter span is greater than or equal to 2 means we use this as one way load distribution method. It means here we are using distance as criteria to its stiffness. How you already know the two ways load is distributed like this and one way load distribution is like this, half portion this side and half portion this side. So here distance is becoming the criteria to its the slab's stiffness, but in shell here slab and beam interacts and empirical T-beam action is actually generated based on stiffness. Okay. So now you know the difference between membrane element and shell element. The difference is in membrane element in plane bending stiffness is present, out of plane bending stiffness is not present. Here both are present. So in plane means it resists the, here in plane resists the loads, here out of plane not present due to not presence of out of plane stiffness. So the load will be transferred 100% to the beams. Here first it will resist some load and then it transfers to the beams. Okay. So you can see the load distribution is as per yield line theory. You know the yield line theory, and here it is based on stiffness of the beams and slabs. So like this we have the differences. Now for which one we have to use? We have to model as membrane or shell thin. For small size buildings, medium size buildings and large size buildings, not only these criteria, small, medium and large, we have some other criteria also to decide which one we have to use the slab as membrane or shell. So we discussed the all criteria in depth in our course. So you can enroll our ETABS consultancy ETABS course in our website. Visit www.ehbconsultants.in. Here you will get the consultancy ETABS course. You can enroll. Okay.